Okay, so in this video, this is section 7.3, and we're going to actually be talking about long division. And so what I have here on this first slide is just the anatomy of a division problem. This guy is our divisor. That's what's on the outside. That's what's being factored out. Okay? This is what we're factoring it out of. Okay, so this would be like our equation, and this is what's left over. Okay, and so our quotient is our solution, right? The dividend is the originally equation, okay, and the divisor is the factor, what we're pulling it out of. Quick review, we want to think about long division. How would I divide this 12,364 by 5? Okay, so let's just go through this because it's a very similar process, but we're going to be using polynomials, which makes the level of difficulty a little bit greater. But so 5 is our divisor. We're factoring it out of 12,364, so this is our dividend. And so we ask ourselves, how many times can 5 go into 12? Okay, well, it can go in 2 times. So we do 2 times 5, and that is 10. We subtract and get 2. And then we drop down the very next number because 5 can't go into 2 anymore. So we get 3. We say, okay, well, how many times can 5, I want to erase this, oops. How many times can 5 go into 23? Well, that's 4 times. 4 times 5 is 20. Subtract 3. Drop down to 6. How many times can 5 go into 36? Well, that's 7 times. 7 times 5 is 35. So on and so forth, and we keep on going. We're going to go ahead and find the quotient. We're going to talk about how to write the remainder also. So I'm going to start cruising through this. 5 times 1 is 5. 5 times, drop the 4. So let me erase this. 5 goes into 14 2 times. 5 times 2 is 10. I have 4 left over. So this guy right here is my quotient. Okay, and the remainder is going to be 4 over 5. I have 4 out of the 5 left over. This guy is my remainder. Okay, that's important because it's how we write when we're dealing with polynomials. We need to write the remainder an appropriate way. Okay, so on to our problem. So what we're going to do is we're going to use long division to divide these two polynomials. Here's the thing. It is very difficult to factor this out of this just mentally doing it like we do with all the other type of factoring that we've done before. Okay, so this is the process that we would use to factor it out. It may come out cleanly. We might have a remainder. We don't know. But we're going to go ahead and use long division to actually factor the x squared plus x plus 2 out of the cubic function. So we're pulling a quadratic out of a cubic. So first things first, I have my dividend, which is my original equation. So the one on the left, this always goes underneath the brackets. And one of the things that we need to make sure that we do, I'm going to draw my division bar. And I'm going to do x cubed minus x squared. Notice I'm missing an x to the first. So what I put in is an x to the first, but multiplied by 0. It's not technically there because of the 0 times it, but it provides a placeholder for any of my x to the first powers. It actually creates a way to organize my work appropriately. Okay, so this is the dividend, and the divisor is what's on the right side of the equal sign. Okay? Okay. So here's the process that we're going to go through. We're going to look at this guy, this first value right here, this x squared. We're going to look at the x cubed. What do I multiply the x squared by so it matches the x cubed? Okay? What do I have to multiply x squared by so it's the same as this guy right here? Well, that's x. It's just x. So where are my x's by themselves? They are right here. So now what I do, my work is, I'm going to take this x and multiply it by every piece of this quadratic. And that's going to be my line in my long division. So I'm going to take x times x squared. That's x cubed. I'm going to take x times x. That's x squared. I'm going to take x times 2. That's 2x. Then long division says that I subtract these guys. So x cubed minus x cubed is 0. I got a negative x squared minus a positive. So that turns negative, right? So what I do is I change this to a positive and change all my signs. So that's going to give me a negative 2x squared minus 2x. And then I drop the leftover number. Okay? And now I repeat the process. So now I'm going to find out what number do I have to multiply this by so it matches the first one in this line. Well, that's a negative 2. So I'm going to multiply negative 2 times x squared. That is a negative 2x squared. And I'm going to take negative 2 times x. That's a negative 2x. Then I'm going to take a negative 2 times 2. And that's a negative 4. And if we look here, we subtract these guys. Because of the subtraction, change the sides. These are all opposites. So what's left over is 0. So look at what we have here. This guy is my remainder. So remember, we have that factor theorem, which says that if I have a remainder of 0, or what's left over is equal to 0, then this guy is a actual factor. So the answer that I'm looking for is x minus 2. This is my quotient. So based on the wording of the problem, the solution is x minus 2. Okay? But let's discuss some of the vocab. So what that means is if I take x minus 2, that's our solution, and multiply it by what our divisor was, that's going to equal our quotient. And so this guy is the factored form of the initial problem. Okay? And that's why we use long division, because sometimes we can't use the mental processes that we go through to factor. We need to use another method to break it down, and that's how we break it down.